Because
regardless survey.
Say it one more time.
Regardless survey. X is always the constant. So
Yeah. All right, you want to do another like that, or you want to do some more basic things?
I have a question about the curve.
Hold on time.
Knowing the area, can you find the length of the actual curve?
Can you find length of the curve?
Yeah, but because you know the area.
Next
also-
semester.
Huh?
Next semester.
Calc 2?
Yeah. Arc length. You find length of curves.
Yeah, because I realized we have like everything
No,
we
you
need.
do, no, it doesn't work like that. What do you suggest?
Well, we have like the sides, we have the area, one of the missing, like, we
Right,
have
it's
all
not. It's not a
variables.
regular. It's not a regular geometric shape though.
Yeah.
So it's not some like simple. I'll divide out by the base or something like that. And get the. You're thinking about perimeter.
Yeah, like,
You don't have the perimeter. You don't know what the perimeter is. You know what the area inside is. And how the perimeter relates to the area in arbitrary curves is this. I know when it's a square, you know, I can figure something out, or a circle, but. So knowing the area does not reveal the length of the curve.
yeah, because there isn't a formula for that.
Correct. Exactly. That's the whole point of what we're doing here. We don't have formulas for this.
Yeah, I was thinking, I was like, that looks like a triangle, but you can't use a triangle. It's not a triangle.
Not a triangle.
Yeah.
It's a smooth curve there, right? An arbitrary one. I figured extra minus one out of thin air. Could have been anything.
I wonder if you can like,
Actually, it's number 49 almost. All right, so I'll just give you a couple of properties that this symbol has. Now we know what it stands for. I already told you a couple of them when we were talking about indefinite integrals and derivatives to make the ideas there a little bit easier, even though they don't mention it in the textbook. But, for example, we have the integral, a definite integral from a to a of some function. You should be able to tell me the answer to this just by intuition alone. What is the answer? Integral from a to a.
A. 0.
Why is it 0?
So no moving. So same.
No movement. There's no area. You're staying in the same spot. Right? Remember that these are x values. You're traversing from one location to another location along the x-axis, and that gives you the breadth of your area. If there's no breadth to the area, there's no area. Right? That's one way of looking at it. So this answer is always 0. If the limits of integration are the same, the answer is always 0, for that obvious reason. The other reason you could say is if delta x is b minus a on n, and in this particular case, delta x would read a minus a on n for some finite a, which is non-zero, then this is 0. If this is 0, then 0 times whatever this function value is 0, I'm going to have a big pile of zeros, right? So it doesn't do anything. All right? Integral from a to b of f of x dx is equivalent to the negative of the integral from b to a of f of x dx. So again, why should that be true necessarily? What does this say? All you're doing is traversing the area the opposite direction. Instead of moving from leftwards to rightwards, the area is being computed from rightwards to leftwards. Why should that make a difference? It really shouldn't so much, except that in this formula again, if delta x has a and b switched, if this was positive a minute ago, and you take a minus b over n, you're going to get the negative of b minus a over n, right? Well, once you put that in here, then that negative can push the outside of the whole thing. It's just negative 1. So it negates the entire original result. Okay? That's one way of looking at it. What's this definition? I'm not sure it's the definition. Anyway, so those are the two main properties I didn't show you before. They weren't really that relevant because you didn't have. This is all about being definite, and then it has the exact same properties described previously. The definite integral has the same properties as the indefinite. If you should have a sum or difference inside of here, then that's the same as separately computing them and adding afterwards. E of x, E of x, and a multiplicative constant still comes to the outside. And for the same reason we mentioned here, remember that this symbol means this summation. So therefore, if you had a multiplicative constant on f, it would remove itself from the outside of the limit entirely. So C integral f of x dx must be true as well. Being A, B, those are the main properties of definite integrals. The two I showed you already, and the two that deal specifically with the fact that they are definite. Alright, so now we'll take some simple problems in the textbook. I'm just going to bore you out of your door now that you saw that awesome spectacle a moment ago. I'm going to take number 23. It says net area and definite integrals. You should know how to do this process. I'm going to give you one of these on the fourth exam. Now, the variety from which it will come is pretty small, right? These problems occupy, doing the full Riemann sum there, and running the limit, really there's not so many, like 45 through 50 in 5.2 is the last problems before the problems get crazy. So it's going to be one of those in there, 45 through 50. You should just prepare them and be ready to produce it. Or just chalk it up as 5 points lost in an exam. There's no big deal, right? Can't hurt you that bad. All right, anyway. So number, what is it? 8? Number what is it? 23. There's 8 in it. So 23. The integral from 0 to 4 of 8 minus 2x dx. Again, this has nothing to do with antiderivatives as of yet. We're not applying any rules about antiderivatives. That'll be in the next section. But at the same time, we don't have to apply the limit definition we just used a minute ago. The problem says use geometry, not Riemann sum, to evaluate the following definite integrals. So that means I need to draw the picture of this thing and interpret it geometrically, and it should conform to some basic formulae for well-known polygons. Okay? So 8 minus 2x. It has a y-intercept of what? Okay, 2, 4, 6, 8. There. Negative 2, negative 4, negative 6, negative 8. And negative 2x is the slope. So, or negative 2 is the slope. So I got to go down what? Down 2 to the right 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to really mess it up here and I'm going to make the scales different. So this should go through right about here. Agreed? If the scale is what I say it is because I said so. What's that?
Isn't this just more complicated?
Well, let's make sure. So from 0 to 4 is what we got to calculate, right?
Yeah, that's what I'm saying.
Oh, okay, if you recognize that. You got to be careful because okay. So yes, it certainly is. Right? Going from 0 to 4, which are the limits of our definite integral here, then it certainly is just a triangle, and you would find the area of that triangle. That's all it is. No reason to use some crazy Riemann sum limit definition for that, right? That should be a waste of time. Although it make you 10 times smarter, but whatever. So, what is the base in this case? 4. Be careful with the tick marks here. And the height? 8. So we know the answer is now what? 16. Right. The answer is 16. So now let me, you guys okay with that, right? Okay. Now let me just change the problem slightly. Change the problem slightly. 0 to 7 now.
Just replace the 4.